everyone, welcome back to Reshmi's Corner. Today we are here with our exercise 1.2 of real numbers. So let's move on to our first question, which is express each number as the product of its primes, and our first question is 140. So let's first do the prime factorization of 140. So 140, 2 70s are, again 2 35s are, 5 7s are. So now we are going to express the given number as the product of its primes, which is 2 into 2 into 5 into 7, which you can write it as 2 square into 5 into 7. So this is how we represent the given number as the product of its primes. So let's move on to the second question. So now this is a second question, which is 156. Now we are going to prime factorize 156. By 2 it goes 78. Again by 2 it goes 39. Again by 3 it goes 13. So what are the prime factors of 156? 156 is equal to 2 into 2 into 3 into 13, which can be written as 2 square into 3 into 13. So now let's move on to question number 3. So this is a third question to prime factorize 3825. So let us do the prime factorization of 3825. 3825, it goes on 3 and you get 1 2 7 5. Again it goes on 3, you get 4 2 5. Again it goes on 5, you get 85. Again it goes on 5, you get 17. So how do you write it as the product of prime factors? You write it as 3825 is equal to 3 into 3 into 5 into 5 into 17, which can be written as 3 square into 5 square into 17. So this is our answer. Now let's move on to our next question. This is our fourth question, which is to prime factorize 5005. So let's do the prime factorization of 5005. It goes by 5, you get 1001. It goes by 7, you get 143. Again it goes by 11, you get 13. So what is the prime factorization of 5005? It can be written as 5 into 7 into 11 into 13. So this is our answer. Let's move on to our next question. This is our fifth question, which is 7429. So let's first find out the prime factorization of 7429. It goes by 70 and you get 4 3 7. Again it goes by 19 and you get 23. So how can you write the prime factorization of 7429? You can write it as 70 into 19 into 23. This is how you represent it as a product of its prime factors. And this is our answer. So now let's move on to question number 2. This is a second question, which is to find the LCM and HCF of the following pair of integers, and you need to verify that LCM into HCF is equal to the product of the given two numbers. And the first question, which is given as 26 and 91. So let us find the prime factorization of 26 and 91. 26 you get 2 13s are. 91 you get 7 13s are. So 26 you can write it as 2 into 13, and 91 you can write it as 7 into 13. So now what is the LCM? LCM is equal to 2 into 13 into 7. 2 into 13 into 7, which is 182. Now, what is our HCF? Highest common factor, which is 13. So, HCF is equal to 13. Now, what is our LHS? LCM into HCF. So, let us find our LHS, which is LCM into HCF, which is 182 into 13. You get the answer as 2366. Now, you go for the RHS, which is to find the product of the given two numbers, which is 26 and 91 here. So, our RHS is 26 into 91, which again you will get it as 2366. So we have proved that LHS is equal to RHS. So now let's move on to our second question. This is our second question, which is 510 and 92. So first let us do the prime factorization of 510 and 92. So 510 goes by 2. So you get 255. Again it goes by 5. You get 51. Now let us do the prime factorization of 92. Goes by 2. You get 4, 6, again it goes by 2, you get 23. So let us take down and write the prime factors. 510 can be written as 2 into 5 into 51, and 92 can be written as 2 square into 23. Now let us find the LCM and the HCF. So what is our LCM here? LCM is
2 square
into 5 into 51 into 23. You will get the answer as 23460. Now what is our HCF? Our HCF will be the highest common factor, which is 2. So now let us find out our LHS. Our LHS is the product of LCM and HCF. So our LHS is LCM into HCF, which is equal to 23460 into 2, and you get the answer as 46920. Now let us find out the RHS. What is our RHS? RHS is the product of given numbers, which is 510 into 92. So 510 into 92, again you get it as 46920. Therefore, LHS is equal to RHS. Hence, proved. So now let's move on to our next question. So this is our third question, which is 336 and 54. So let's find out the prime factorization of 336 and 54. 336 goes by 2, you get 168. Again it goes by 2, you get 8, 4. Again it goes by 2, you get 4, 2. Again 2, you get 2, 1. Again by 3, you get 7. So how do you write 336? You can write it as 2 raised to 1, 2, 3, 4. So 2 raised to 4 into 3 into 7. So now let's find out the prime factorization of 54. How do you get that? Again by 2, 2, 7, by 3 you get 9, again by 3 you get 3. So how do you write the prime factorization of 54? 54 is equal to 2 into 3 cube. So now let's find out the LCM and the HCF. So what is our LCM? LCM is equal to 2 raised to 4 into 3 raised to 3 into 7. So that is 2 raised to 4 into 3 raised to 3 into 7, which is 3024. Now let us find out the HCF. Now what is the highest common factor here? Highest common factor is 2 into 3. So that is 2 into 3, which is equal to 6. Now let us find out the LHS and the RHS. So what is our LHS? LHS is LCM into HCF, which is 3024 into 6, and you get the answer as 18144. Now let us find out the RHS. What is our RHS? 336 into 54. Our RHS is 336 into 54. Again you get the answer 18144. That implies LHS is equal to RHS. Hence proved. Now let's move on to our next question. So this is a third question, which is to find the LCM and HCF of the following integers by applying the prime factorization method. So first let us find the prime factorization of given three numbers. So that is 12. How do you find the prime factorization of 12? 2, 6 are 2, 3s are. So I can write 12 as 2 square into 3. Next I am going to find the prime factorization of 15. So that is 3 5s are. So 15 I can write it as 3 into 5. Next I have 21. How do I find? 3 7s are. So I can write 21 as 3 into 7. Now the question is to find the LCM and HCF. So how do you find the LCM, which is the least common multiple? Which is the least common multiple? It is 2 square into 3 into 5 into 7, which is 2 square is 4, 4 3s are 12 and 7 5s are 35. 12 into 35 you get 420. Now, what is our HCF? HCF is the highest common factor. What is the highest common factor here? It is 3. So, we found out the LCM and HCF, which was our question. Now, let's move on to our next question. Now, this is our second question, which is to find the LCM and HCF of 17, 23 and 29 by prime factorization method. Now, what is the speciality of all these three numbers? There is no need of finding the prime factorization. So, how do you find the LCM? LCM, the least common multiple, is equal to 17 into 23 into 29. You get the answer as 11339. Now, what is the HCF? HCF is the highest common factor. Now, what is the highest common factor of all these three numbers? It is 1. So, HCF is equal to 1. So, this is our LCM and HCF. Now, let's move on to our next question. So, this is our third question, which is to find the LCM and HCF of 8, 9 and 25 by prime factorization. So, first let us do the prime factorization of 8, 9 and 25. 8 2 4s are, 2 2s are. So 8 can be written as 2 cube. Now next is 9, 3 3s are. So 9 can be written as 3 square, and 25 can be written as 5 into 5. So that is 25 can be written as 5 square. Now what is the LCM least common multiple? LCM is equal to 2 cube into 3 square into 5 square. 2 cube into 3 square into 5 square, which is 1800. Now, what is the HCF? Is there any common factor? No. So, what is our HCF? Our HCF is equal to 1. So, this is our LCM and HCF. So that was the last question for today. We'll continue our exercise 1.2 in our next session. Till then,